So although we came a long way in that last video and we configured our very first Palo Alto virtual firewall, as you can see here, we completed each of these activities here, but there's many more left. So I'm not really going to hold you. We're going to jump right in and start the basic configurations for the Palo Alto settings, as well as ensuring that we have reachability for a host that I've went ahead and deployed. And for that, we need to also update our AWS route table. So let's go ahead and start with configuring the host name, DNS settings, and NTP. Got the virtual machine spun up. So let's click the device tab. This tab hosts most of the settings for the firewall itself. Here on the left hand side, this pane has a lot of the various features, and we're going to run through it the rest of this mini series, but we're going to stay here in the highlighted setup, and then underneath management, we'll click the gear icon here to edit, and let's go ahead and change our host name, and let's go ahead and name it the same POC Palo Alto Firewall AZ1. We'll keep the domain blank for now. Accept DHCP server provided host name. We'll check that. Actually, let's uncheck that. We'll force it to be this. And then we don't have a login banner. We don't need it for now. No certificate just yet. And I'm going to change this to the US East. Let's see if we can type EST. There we go. And that should be it for those primary settings there. Then if we come underneath services, we'll do the same thing. We'll click the gear icon, and right here for the primary DNS, AWS actually has for Route 53 the resolver, or what other folks call the AWS DNS server. That address is actually 169.254.169.253. Secondary DNS server, we'll just put 88888 there. And then for NTP, we'll actually again use AWS's NTP server, which is 169.254.169.123. And we won't use a secondary NTP for the time being. No authentication required. So that is all that we need to complete that task there. Check that out. Now onto the network settings. If you recall in the last video, when we did a show interface all in the CLI of the firewall, we didn't see any. And again, that's because although we have those elastic network interfaces or ENIs attached, we actually don't have the firewall or the network settings for those interfaces configured here. So let's start by creating two different zones or security zones. Kind of a zone-based firewall. We will create one by clicking here, the add button. We'll do it inside and outside. So let's just basically make that the name. We'll say inside, and we'll come back and do a VPN when we get to the global protect setting. Both of these will be layer 3. We'll leave the interfaces off for now. Enable user identification. We'll check that. Zone security profile, we don't have one set, but we'll come back and do that in a future video of this series as well when we get to the various security subscriptions that we have. So that was the inside. We'll do the same outside. Layer 3, no interfaces. We don't need that check for the outside. Let's click OK. Those are our two security zones. And so moving right along to the interfaces. So we know that ETH11, the second interface, is actually our inside interface. So let's click on that. And so here for our inside interface, let's go ahead and type inside there for a comment or the description. This will be a layer 3 interface. And I like to go ahead and set the link state to up. So let's change that value. Here for underneath the IPv4 tab, we can go ahead and click DHCP client and it'll pull the proper IP address from AWS. For the inside interface, we can deselect this automatically create default route pointing to the default gateway. We'll leave that check for the outside interface. Underneath advanced, management profile, this is the inside. We will go ahead and create a new one, and for both, or actually, maybe we'll make it different. This will be inside. Management profile. We will permit SSH if we did have another host that was trusted on the private. We will permit that, and we won't allow HTTP or HTTPS for now from anywhere else, but we'll allow ping from the inside, and that should be good enough. And this again is our inside interface, and that's all we need. So let's click OK. All right, this link state should change to green, or sometimes we actually do have to restart the firewall for that to take place. I've had both happen with Palo, where sometimes the backplane will automatically catch it, and sometimes you actually, like I said, have to do a restart. All right, so for ETH1.2 or the third interface, this is outside layer 3. Link state we will change to up. Management profile, we will go ahead and make a new one. This we will allow or permit HTTPS, SSH, ping, response pages. We'll go ahead and do that. That again is for our client VPN. When we get there, this will be outside management profile. All right, let me pick up the pace. All right, so that's our two interfaces. I'm looking here, double checking. I missed the security zone, so let's go back to both of these. All right, there we go. Very first tab, probably. There we go. Virtual router, we will use default. Security zone. This again is inside. Now we'll click OK. Read the warning, and we'll select yes. ETH1.2, outside. Same thing, but of course the security zone will be outside. So we'll select default for that router. Outside for the security zone. And after reading that warning there as well, we'll go ahead and click yes. I missed something else. DHCP client. Oh man, rushing through. Apologies there. All right, let's see. IP address. IPv4. Let me run through each of these tabs. Don't need a tag. Not doing a virtual wire. There we go. There we go. Leave that checked. Yes. All right, so I think we're good to go here on our interfaces and our zones. Okay, no loopback or tunnels just yet. Now for our virtual router, we do need to do the routing here inside of our firewall. So let's go ahead and take care of that now since we're on the networking tab. So underneath static routes, we'll need 2. So we'll add one for reachability to the internet, which is basically our outside interface that's going to point to its default gateway. So this is going to be default route. Destination is any unknown, quad 0/0. This interface will be, of course, ETH12. The next hop, let's see if we pull over our Visio. All right, there we go. So our outside interface .40 means 16 for that. 32 is the network, so .33 is going to be the default gateway there. So 10.100.0.33. All right. No need to change the admin distance. And we'll click OK. All right, so that's our first route. And then for anything that, we'll just do the entire VPC. 10.100.0.0, or actually that's not the name. Let me cut that out. We'll use it below. This will be, we'll call it internal. And then we'll call that /24. All right, there we go. Interface, let's go ahead and select ETH11. Next hop, again, this is .20, so .16 is the network ID, so .17 is the default gateway. Likewise, we'll leave the admin distance blank, and those are the only two routes that we need. Again, for any host on the inside, if we set up a virtual Linux box test instance, which I actually have done, if it needs to reach the internet, that unknown route, it's going to have to go through this outside interface for the return path to get back to that Linux box. The private IP, of course, is going to be within this range, so it'll go across the inside interface there. So let's hit OK. All right, so there we go. And that should be good. Let's go back to our checklist. So security zones are good. Interfaces are good. Static routes are good. Now we need a good old security policy and a NAT rule. All right, for now, definitely not the safest thing to do from a security perspective, but I'll power down this firewall right after. There is, of course, this, people call it implicit, but it's kind of explicitly here. These two rules that, of course, are this explicit deny at the end. The rules, of course, are matched, or I should say, evaluated from top down. And if none of them match, then, of course, there's that default deny for anything that's going interzone, coming from the outside to the inside or inside to the outside. Intrazone, inside, outside, outside, is of course trusted. So we need to add a rule. We will just call this a basic rule because this is not going to be here permanently, but we'll call this our basic rule for now. Description, this is the first rule created to permit initial setup. We'll say something like that. We won't do any tags just yet. Source, which is not good to do. We'll do any, same destination, any destination zone, going to any address, application, any service, application default. And then here you'll see by default, there's just the HTTPS and HTTP. So that's why we're keeping that as any. An action will be allow or permit. We will log this at session start and end. We don't have any syslog or any log forwarding just yet. In our profile settings for our security items, threat, protection, URL filtering, etc., we'll come back and do that as well. So for now, we'll leave that as none, but this will suffice. And as you can see here, that automatically places it up top. Now we do need to do a NAT for our hosts that are on our inside zone. For them to communicate across the internet, they have a private IP address. They don't have a public IP address to communicate on the internet. So the firewall will do the NATing for them, and vice versa for the response. It'll basically translate that public IP address back to the private IP address. So for this, we'll do the same. We'll do initial NAT, or well, actually, this is we'll call this NAT outbound. This description is NAT statement for internal hosts to reach the internet, basically PAT. All right, so original packet. So our source zone here is actually going to be the inside. Destination zone, as you can guess, will be the outside. That interface is ETH12, our outside interface. Source address destination, we're not going to mess with that for now. Translated packet, we're doing source NAT. We're going to be NATing our internal host with a private IP, and we're going to be using, of course, the outside public IP address of the firewall. So that's going to need to translate the IP and the port. So dynamic IP and port translated address, we will change that to interface address and select ETH12 or the outside interface, and we'll leave that as none. We will click OK. That's our first NAT, and when we do testing down the road, we'll see that that hit count should increase if we've properly set that up. So we have both our security policy and our NAT rule configured. All right, so the last thing to do, validate the interfaces. But before we do that, for any of these changes to take effect in Palo Alto, we must first commit the changes. So let's go ahead and do our very first commit. Our description here will be first commit basic configurations. There we go. So we'll click commit and we'll wait just a bit. But while that is waiting, let's go ahead and get on back into our firewall here. Let's go ahead and double click. I've saved that key as well as the username. So we should be able to get right in without being prompted for our username. There we go. All right. So let's, and what I want to see, although the firewall, I don't think that commit went through yet, is to see if our interfaces are visible from the control plane, because if they're not, then no forwarding of traffic can of course occur. So let's do show interface all. Okay, so now we do see ETH11 and 12. Of course, last video we did not see those, but last video we did see our management. We did see the .10. We now see .20 and .40 respectively, inside and outside. So we have our zones, our virtual sys. Of course, we're using the default router, our virtual router there. Okay. Now, if we do a ping here to like 888, Google's DNS, then hosts, apologies, got to preface the there with the host. We can see that we can get out. But the reason is because the management plane by default on a Palo Alto firewall is used to source those pings. So what I've done is I've actually, if we come here, we see that I've set up a Linux AZ host, and I've done that in the inside interface. There is no public IP addressing, so this has only private reachability. So although that firewall can ping out, you may be fooled by thinking that we have connectivity. But what I've done to not have to put a public IP address here and fake the funk is I've gone ahead and configured an endpoint so that we can actually connect through our private firewall and trust the IAM role that's attached to the EC2 instance. So if we come back here, we click connect. We go to connect using EC2 instance endpoint, and we select that endpoint. We will be able to be trusted by the IAM role that was attached to that endpoint. And because our user, of course, is also trusted, then we can establish that connection without needing to use the SSH key pair or to have a public IP address on this host. And what I want to show you is that this ping out to the same destination 8.8.8, 8.8.8.8, 4 eighths, should not work. Although the routing and the firewall is there is something missing. And so let's walk through this real quick. All right, so as we can see there, this is me moving the mouse, not pausing this screen or anything there. We'll see that none of those requests are actually going out. 9 transmitted, none received. So if we come back here to our firewall, we see that first commit actually went through, no errors. 507, not sure what that commit was there. Oh, our time is changing as well, back to East Coast. All right. But the reason actually is because we'll show you here real quick. Oh, not there. Checklist. We did validate our interfaces, but the last thing we need to do is update the AWS route table. So if we go back to our VPC service and we click route tables, our management route table was the very first one we set up. This is the route table that is associated with the firewall's management interface, ETH0, that we, of course, don't see as E11 or 112. But this is pointing to the internet gateway, and because it has a public interface, it is actually allowing us to communicate across to our device. Now let's see. If we go to our outside interface, we see that this as well is pointing to the internet gateway, but we now actually need to put an elastic IP address here. That's one thing that we need to do. So let's go back to EC2 instance tab here. We'll go ahead, actually we'll hit EC2. We'll select elastic IPs. We'll allocate, or actually we have one allocated here. Let's go ahead and edit this. Copy that, and let's scroll to the right, make sure it is available. Hit this gear. All right, well, we'll hit that. Let's rename this, and we'll go ahead and associate this to ETH2. This will be outside. 1, 2, 3, 4. We'll hit save. Let's associate this elastic IP. Network interface. We will select the outside interface of our Palo, and we'll allow it to be reassociated if we need to temporarily use it somewhere else. So now we have that associated there. That's done. Let's see if we can ping out. All right, and we see that we still cannot ping. All right, let's take a look back in our firewall. We'll take a look at monitor. By default, we should have the traffic tab up. And let's see what's going on here. No data coming through. So that host that sits on the inside subnet, traffic's not even making it here. All right, well, let's go back here and take a look at the inside route table, which of course the subnet associations are proper, the inside interfaces. But if we look at the route table here, there's only local reachability within the VPC. So what we need to do is we need to ensure, pull over the Visio. Here we go. So for any host, like if we had that Linux host that sits right here and the same subnet as this inside interface, right now it doesn't know where to go. If it's pinging 8.8.8, that's not within that /24. So we need to direct all of that traffic towards this inside interface so that we can get those requests into the firewall. And then the firewall will look into its virtual route table and say for any unknown address, we need to go to the outside interface, hit that gateway of .37, which will then send it to the internet gateway. And then that's how we should route that traffic out. And of course, the response will be the reverse. So now let's go ahead and hit add route. And so for any unknown address that's basically outbound, we will use the network interface and we will send that to the inside interface of the firewall. So if all went well, we should now start not only being able to ping, but we should also see that traffic inside the firewall. And if not, we may need to restart the firewall to get the control plane working. But let's see. Control C there. Let's see if we see anything here. Do we see data now? Nothing there. All right, let's go back to our device. Check a few more things. All right, let's see. Let me go to software. This may be a base version. No update available. Ooh, one important thing to do as well, troubleshoot on the fly. I love it. I think I thought of this and wrote it down. Didn't write it down. One thing that we also need to do, and this is one that's easily missed, is because it may be in the documentation, but for the data plane network interfaces, by default, if we click on, let's say, the inside interface, for instance, we'll see that this source destination check is actually true. And what this means is that any EC2 instance, if it's not the destination of the packet, then it will actually drop that packet. So because a firewall needs to perform NATing, which is what we're doing now, or it can perform NAT, but we're using it to do that, then our firewall is not the destination of this packet. We actually need to disable that source destination check for both the inside and outside interfaces. So let's hit save. That's the inside. Didn't mean to hit the pencil icon. There we go. We'll uncheck that. All right, let's see. Without refreshing, yeah, it's false. All right, so let's see what we got here. All right, no. There we go. So no restart needed, just mentally thinking this through. All right, so we see that now our traffic should be making it into our data plane. Let's go back to monitor. Traffic should be coming in. I won't say flooding. There we go. Pings coming in from .21, which is the IP address of that Linux host. Source zone is inside to the outside. Destination 8.8.8. If we click on this magnifying glass, we'll get a little bit more details. Again, this isn't a production environment, so we don't have a bevy of applications, tools, different protocols that we can see. We hit this little window here, we'll actually maximize this. But we can see that there's the different size of the packets, a few more details about the host and destination. If we were doing filters by country, this is, again, the United States. So just a few different kinds of information, and we'll see when we start getting threats how this can be populated with different items there. But for now, if we were to refresh this again, we should start getting a few more packets. There we go. All right, cool. And likewise, we'll do one more. We'll just do a curl, basic curl Let's see, curl https espn.com. Should be a wealth of information coming through the front page of espn.com with all the bowl madness going on. And go Niners and go FSU. So we'll just come back here again, but we're pretty much done with our basic initial configuration. So much more to configure. May go live to actually get that done, but we'll see how it goes. There we go. SSL, HTTPS to this destination. That's the ESPN stuff right there. So cool. So we're going to go ahead and check off validate reachability. And of course we configured the AWS route tables, and we didn't even need to restart the firewall. So there we go. But I want to thank each and every one of you again that's hung in here with me through these first few videos of this mini series. It's an awesome experience, and we're nowhere close to being finished. But again, if you haven't caught those first few videos and you feel a little bit lost, then go ahead and check out one of these videos. But until next time, I want to thank each and every one of you for rocking in here with me today. Stay safe, take care of yourselves, and peace.